right, here we are, lesson 7.3, and we're looking at decomposition of partial fractions. So these are the notes that you printed. If you need to pause and go print the notes, then go ahead and pause and print the notes. And we're going to start with this warm-up problem here. So take a moment to do the warm-up problem, pause the video, and when you're finished with the warm-up problem, restart the video. All right, so let's see how you did on the warm-up. You should have gotten this answer, x plus 7 over the quantity x squared minus x minus 6. Now, we've been working with rational expressions and adding. We've added, we subtracted, we multiplied, we divided. We also graphed rational functions. So we've been working with rational expressions in a lot of different forms since Algebra 2. And so today what we're going to be looking at is we're going to look at how do we decompose a rational expression into what we call partial fractions. Okay, so now what does that mean? So decomposition of partial fractions really means we're going to kind of take a problem that we're used to seeing and we're almost going to work it backwards. So basically, I am going to give you something like this here, and then I'm going to say, I want you to decompose it into partial fractions. So you're going to work it backwards and figure out what were the two rational expressions that were added together to get that x plus 7 over x squared minus 6 x squared minus x minus 6. So as you can see here in this bullet point, it's like we're going to go from the answer back to the problem that we're used to seeing. Okay, and that's what we call decomposition of partial fractions. Okay. All right, so let's take a look at an example. Number 1, how do we decompose into partial fractions? So the directions, I forgot to type them. They should say decompose into partial fractions. All right, so here we're going to start with the simplest. So we have 5x minus 10 over the quantity of x plus 2 times the quantity of 2x minus 1. So the very first thing that you're going to do is you're always going to start by factoring the denominator. Okay. You're going to factor the denominator. You're going to see if it can cancel with anything in the numerator. In this case, it cannot. So then we're going to continue on and start decomposing. So whenever we decompose, we need to figure out how many fractions do we have to add together in order to get this answer or to get this problem. And in this case, we're going to have 2. The reason I know it's 2 is because I have 2 factors in the denominator. So I break this up into 2 partial fractions. Each of the fractions is going to have one factor as its denominator. So one of my factors is x plus 2. So I put x plus 2 as my first one. And then I put 2x minus 1 as my second one. Now I have to figure out the numerators. Okay, the numerator is an expression that is 1 degree less than that denominator. So numerator is an expression that is 1 degree less than the denominator. So in both of these cases, the denominator degree is a 1, x to the first, 2x to the first. So my numerator has to have 1 degree less than that. Well, 1 degree less than 1 is a 0. So my numerator is going to be some coefficient times x to the 0. So ax to the 0. And then my second denominator, or my second numerator, is going to be some coefficient, make sure you use a different variable, and then times x to the 0. So I have ax to the 0, and then I have a bx to the 0 as my numerators. Okay? Now, we know that x to the 0 equals 1, so we usually just don't write the x to the 0. So let me get rid of that x to the 0, and let me get rid of the x to the 0. So in this case, we just have a as our numerator and b as our second numerator. Now we want to decompose this into partial fractions. So to do that, we want to get rid of the denominators. So I'm going to multiply this entire equation here, multiply the entire equation by the denominator so that I can cancel it. So I'm going to multiply the whole thing by the quantity of x plus 2 times the quantity of 2x minus 1. Now, when I multiply this times the left side of the equation, both of the denominators, the x plus 2 and the 2x minus 1, are going to cancel. And all I have left then is 5x minus 10 equals. Then I'm going to multiply by the a term, and my x plus 2 is going to cancel with the x plus 2. So I'm just going to have a times the quantity of 2x minus 1. When I multiply it by the third term there with the b, my x minus 1 is going to cancel. So I'm simply going to have b times the quantity of the x plus 2. All right, so we've gotten rid of the denominator. Now we're going to expand out, and then we're going to regroup. Okay, and this is one method for solving to doing decomposition of partial fractions. There are other methods, but I'm going to teach this method because it will work all the time, even when you get to the complicated ones. So on the left, I still have my 5x minus 10. On the right, I have 2ax minus a plus bx plus 2b. And now I'm going to go ahead and I'm going to group together the terms that are like terms. So on the left, I simply just have my 5x minus 10. On the right, I have 2ax that has an x in it, and I also have bx that also has an x in it. So I'm going to write those next to each other. 2ax plus bx, and then I can see that I have minus an a and plus 2b. Those don't have any variables, so those are going to be the constants. Okay, now I'm going to go ahead and I'm going to factor out the x from the blue terms. So I'm going to get 5x and then minus 10. And I'm using colors. You're going to see why the colors are the way they are in a little bit. Times the quantity of, I factor out the 2a plus b times x, and then I have plus, and I'm going to group this together and just write it as negative a plus 2b. All right, so I use those colors because I want you guys to see that on the left we have a term that is a linear term of 5x. On the right we have a linear term of the quantity 2a plus b times x. On the left, we have a constant term of negative 10. On the right, we have a constant term of negative a plus 2b. So we know in an equation, the left side has to equal the right side. So that means that the coefficient of x has to equal on both sides. So that means I could write the equation that 2a plus b must equal 5. Okay, so that comes from the coefficient here and the coefficient of x on the right. Similarly, I know that this negative 10 has to equal negative a plus 2b. So I'm going to write negative a plus 2b equals negative 10. Now, you might be thinking, oh, well, that's a system of equations. That's why this is in chapter 7. We've been studying systems of equations. So here we have a system. Okay, so after we expand, so I'm just going to write some steps here. So we expand, and then we regroup, and then we write a system of equations. All right, perfect. And then we're just going to simply solve our system of equations. So you guys can go ahead and solve that system of equations. You can pause the video if you'd like. All right, when you solve that system of equations, you can use substitution, you can use elimination, you can use row echelon form with back substitution, which is also Gaussian elimination. Totally your choice. And when you solve that system of equations, what you should get is you should get that a is equal to 4 and b is equal to negative 3. Okay. Now that we know a is equal to 4, b is equal to negative 3, we're just going to write out our final answer. So the final answer is we have our original problem, 5x minus 10 over the quantity x plus 2 times the quantity 2x minus 1. We decompose this into, we said our a was over the x plus 2 plus the b was over the 2x minus 1. So a is 4, b is negative 3. And here we have our answer. Now you can also write that as minus 3 over the quantity 2x minus 1. That's perfectly fine. Okay, there's number 1. That's the easiest kind that we have. Okay, let's look at number 2. The difference with problem number 1 and problem number 2 is the numerators. In problem number 1, the numerator degree was less than the denominator's degree. The numerator had a degree of 1 and the denominator had a degree of 2. Here, the degree of the numerator is equal to 3. The degree of the denominator is equal to 2. So this is an improper fraction. And since it's an improper fraction, first what you want to do is you want to do long division and divide it out into, so I'm going to do, therefore long divide into a mixed number, mixed expression. Okay. All right. So we do our long division. You guys know how to do long division. Do you remember from chapter 2? So I have this 4x cubed plus 9x squared minus 2x plus 6. That whole thing is going to be divided by x squared plus 2x. So we complete our long division. I'm going to go ahead and just give you what the answer is, but you guys can do your long division on your own. So when you do your long division, you can pause the video if you'd like. What you're going to end up with is you have a 4x plus 1 plus the remainder was negative 4x plus 6 all over, you put that remainder over the denominator x squared plus 2x. Okay? So this is what you get with long division. So right now, what we have is we have that this whole quantity here is equal to 4x plus 1 plus negative 4x plus 6 all over x squared plus 2x. Okay, so this part here, the first piece, the 4x plus 1, this represents some integer. Okay, this is still the fraction, so we're going to take this piece and we're going to, if I can spell properly, we're going to decompose. Okay, so we're only taking that second part and we're going to decompose this second part right here. Okay. All right. I'm just going to hang on to that 4x plus 1 for now, and I'm going to decompose the second part. So let me just work on the right-hand side over here. Okay. So decomposing. So I'm taking negative 4x plus 6 over, let's factor the denominator because that's the first step we have to do, x times the quantity of x plus 2. So I have two terms of that denominator, so I'm going to break it up into two fractions. So I have something plus something. One denominator is x, the other denominator is x plus 2. The degree of this denominator is a 1, x to the first, so my numerator is going to be ax to the 0, or just a. My second denominator degree is also a 1, so my numerator is going to be bx to the 0, or simply just b. And we're going to work this problem just like we did number 1. So I multiply everything here by the denominator x and x plus 2. So my first denominator on the left, everything's going to cancel. So I have negative 4x plus 6 equals, here my x cancels, so I simply have a multiplied by x plus 2. For the b terms, my x plus 2 cancels, so I just have plus b times x. All right, I expand it all out. Negative 4x plus 6 equals ax plus 2a plus bx. I can see my like terms, ax and bx. All right, so I'm going to get negative 4 x plus 6 is going to equal, then I have a plus b times the x, and then plus, and I have 2a. So again, I used color coding so you can see we now write our system of equations. So our system of equations says a plus b equals -4, and then 2a equals 6. Notice when I write the system of equations, I line it up so that the a's are lined up here, and then so we can see here the a's are lined up, the b's are lined up, there's no b term in the second, and then our constants and our equals are lined up. So we solve this system of equations and we end up with a is equal to 3 and b is equal to -7. Okay? All right, so now we can take that and we can put that into the left-hand side. So here on the left equals, we have our 4x plus 1, and now plus, we decomposed this into 2 parts. One denominator was x, the other denominator was x plus 2. The a goes above the x, so I put 3 here. 3 goes above the x, and the -7 goes above the x plus 2. And again, I can just write it as, if I want to, -7 over x plus 2. And there is my answer. All right, so that's the case when we have an improper fraction. So you always want to check to see if the numerator degree is greater than the denominator degree. If it is, you want to do long division first and then start decomposing. If it's not, you can start going straight into decomposing. All right, number 3. Number 3 is yet another type of problem. This type of problem is what we call when we have a repeated factor. Okay, so let me just kind of put a star above here. This is a repeated factor, and this has a special case. Okay, so we first start by just factoring the denominator. So you can pause it, go ahead, factor your denominator, and think about what we're going to have to start. So my numerator just stays 3x squared minus x plus 5. Oh, I should mention, I did check my degrees. This is a 2, this is a 3, so I don't have to do long division. All right, when I factor the denominator, I get x, and then I have an x minus 1 quantity squared. This is what I'm talking about as a repeated factor right here. X minus 1 quantity squared. That means that I have an x minus 1, and I have another x minus 1. So we think about this as like 2 factors, right? Because it's an x minus 1 and then another x minus 1. So when I say what this is going to decompose into, I need one fraction for my x plus another fraction for the x minus 1 plus another fraction for the x minus 1. Huh. Well, that would be weird. Because if they're both x minus 1 denominators, then why wouldn't I just add them together? So our second x minus 1, we need to put x minus 1 quantity squared on it. So what you're going to do whenever you have a repeated denominator, you're going to count up to the maximum degree of that repetition. So because we have x minus 1 squared, we need to have an x minus 1 to the first, and then we need to have an x minus 1 to the second. If, for example, let's pretend here for a second, if we had like an x minus 1 to the fifth, then we would have one denominator of x minus 1, then we would have a second denominator of x minus 1 squared, then we would have a third denominator of x minus 1 cubed, then we would have a fourth denominator of x minus 1 to the fourth, and we would go all the way up to x minus 1 quantity to the fifth. Okay, so that's how you work with a repeated fraction, a repeated factor. All right, I'm going to erase that because we don't need that, but I just wanted you guys to have that knowledge for when you have something that's repeated more than just twice as a square. Now, the numerator. My numerator here is an a. x to the 0 because it's actually the first in the denominator. Here, I also have just a b because that's x to the first in the denominator. Here, the factor is x minus 1. So x minus 1, the degree is still just a 1. So since the degree is still just a 1, I just have a c in the numerator, nothing more. Okay? All right. And now we're just going to continue with the same process as we've done on the earlier problems. So we're going to multiply this whole thing by the factors of the denominator. So we have x, and then we have x minus 1 quantity squared. So on the left, everything cancels. So what I have on the left is 3x squared minus x plus 5 equals, then I have a times the quantity of x minus 1 squared plus b. B gets multiplied by the x, and then one more x minus 1, and then c just gets multiplied by the x. Okay, and you can, pause and think about that for a minute. And then I'm going to go ahead and expand everything. Okay, so expanding everything, so I get 3x squared minus x plus 5 equals, then I have a times the quantity of x minus 1 quantity squared. So that's going to give me ax squared minus 2ax, and then plus a. Then I have bx squared minus bx, and then plus cx. So let's go ahead and find our like terms. So I have ax squared and a bx squared. So I have two x squared terms, and I can write those, and I can factor out the x squared. So I'm going to get a plus b times the x squared. And then I have, let's see, x terms. So for my x terms, I have negative 2ax, and I have negative bx. All right. So then I have plus, and I have cx in there as well. Don't forget about that, cx. So then I have plus, and I'm going to group together negative 2a minus b plus c. Okay. And then that's all multiplied by x. And then my constant, all I have for my constant is simply just the a term. So I just have the a. So at the end, I have plus a. So on the left, my 5 is the constant that's going to match. And then I have 3x squareds. And then I have negative 1, so minus 1 times the x term, and then plus 5. So again, following the colors, you can see your system of equations that you're going to write. So I get a plus b. I'm going to leave a space because I don't have a c equals 3. From the pinks, I get negative 2a minus b plus c equals negative 1. And then I get a equals 5. Okay, well, there's our system of equations. Well, that makes it pretty simple to solve since I already know the a value. I can take the a value, plug it into there, and get the b value. And then I plug the a and the b into the pink equation, and I get the c value. So what we end up with for our answer is we get that a is equal to 5, b is equal to negative 2, and c is equal to 7. And of course, you guys are showing the work for the system of equations, but for time's sake, I'm just giving that to you. All right, so then our final answer is we started off with 3x squared minus x plus 5 over x cubed minus 2x squared plus x. We figured out that that was equal to our 3 fractions. One denominator was x, on top of x was the a. Second denominator was x minus 1, on top of x minus 1 is b, so I'm going to put it as minus 2. And then our third denominator was x minus 1 quantity squared, and on top of that is the c value. And there is our third example. Okay, there's one more type that we're going to go over in class. All right, last problem, number 4, just a little bit of a word problem. You're going to see problems like this in your homework. So I just want to go over this equation, make sure you guys understand the equation. And then it's just setting up a system and solving a system. So what's in red is the information that sets up the formula. So the height at time t of an object that is moving in a vertical line with constant acceleration is given by the position equation. So this S equation here, this is the position equation, okay? It gives the position of the object. So S is the position. The height S is measured in feet. T is measured in seconds. V naught, or V sub 0, is the initial velocity, okay? That's in feet per second, and T at T equals 0. So our initial velocity when T equals 0. And S naught, or S sub 0, is the initial height. So we want to find the position equation. So in the end, we're going to write ourselves an equation, this whole equation here, for an object at the given heights moving vertically at the specific times. So in the end, we're going to write an equation, and our final answer is going to be S is equal to, we need to figure out what we're going to have. Well, we're going to have S is equal to 1/2. We need to figure out the A value. Okay, so we need to find A, and then we're going to have T squared, plus we need to figure out the V naught times T, and then plus we need to S naught. So we need to figure out 3 variables, A, V naught, and S naught, and we're going to write it out as an equation. Okay, so we take the information that's given. We're given T equals 1 second, and then S is equal to 104 feet. So I'm just going to go ahead and I'm going to plug that in to the formula that's given. And plugging that into the formula that's given, this is going to give me an equation. And my first equation from this first data point is going to be that 1/2 A times T squared, so times 1 squared, plus V naught times T, which is 1, plus S naught is equal to 104. All right, there's equation 1. My second equation is 1/2 A times T squared, and now T is 2, V naught times T plus S naught is equal to 72. And my third equation, 1/2 A times 3 squared plus V naught times 3 plus S naught is equal to 16. So I just take those 3 equations and I'm going to, write out my system and then solve my system. So just rewriting those equations kind of in simpler format. I have my first equation is 1/2 A plus V naught plus S naught is equal to 104. Then I have second equation simplifies to 2A plus 2V naught plus S naught is equal to 72. My third equation is 9/2 A plus 3V naught plus S naught is equal to 16. So here is my system. And now you guys can use any method that you want to solve this system. You can use row echelon form and back substitution. You can do double elimination that you know from algebra 2. Anything that you want is fine. When you end up solving it, I'm going to let you guys solve it on your own. In your solving it, I'll give you the answer. So you can pause the video and then check to see if you got the right answer. All right. You should have found that S naught is equal to 112, V naught is equal to 4, and A is equal to -24. So I just plugged that into my equation for my final answer. So I have 1/2 times -24t squared plus 4t plus 112. And I could just simplify that. So S is equal to -12t squared plus 4t plus 112. And there we have our final answer. All right, so that is the end of 7.3 day 2, decomposition of partial fractions. Hope you learned something, and I'll see you guys tomorrow.